Welcome for all in the lecture number 10 of Energy Audit. In this lecture we will talk about what we must check for refrigeration and cooling systems and what are the typical opportunities for them, and what we must check for industrial processes and also for compressed air systems, and what are the opportunities for compressed air systems and technical assessment of renewable energy in the field of industrial or commercial sectors. Now, what to check for refrigeration and cooling system? At first, energy editors must check the temperature difference between condensing and evaporating temperature, and also the size of cooling load, and check if there is a potential to use free cooling technologies, and if the plant capacity is appropriate for the current load or no, and also if the plant operates at a partial load for a large portion of time or not. And as we see in this diagram, the refrigeration and cooling unit. The unit comprises from compressor, evaporator, condensing unit, and expansion valve, and cut-off valve, and thermostat, and this is the cold room, of course. And as we see, this is the passages for warm air, and also this is the passages of cold air via the radiator. Okay, and as we see in this diagram that the refrigeration systems, and as we see in this diagram that the air temperature leaving the coil of evaporator must be lower than the cool room set point temperature in order to remove the heat from the inside of this space, and also the relative humidity inside the room is affected by the difference between the temperature set point and the temperature of the coil of the evaporator. Okay, and also we see that the temperature variation allowed switches for on or off at 2 Celsius plus minus 2 Celsius degree. This of course represents the principal operations of refrigeration and cooling system for this specified room. Okay. Also, what to check for refrigeration and cooling system? First, we must check the temperature set point and provide evidence for maintenance plan if there is any difficulties in achieving the temperature required, and also checking the insulation level and moisture ingress, and also if there is high pressure drops in liquid circuits, which indicates for high flow and high pump load that cause increasing for cooling load, and also if there is any leakage in the cold space, and checking design condition temperature difference. The typical value 10 Celsius for evaporative condenser and 15 Celsius for air-cooled condenser, and also if there is if there is 1 degree Celsius increase in condensing temperature, it will cause increase in running cost by 2% to 4%. Okay. Now for the typical opportunities of refrigeration and cooling system, as we will see, by using free cooling, This can be used when process temperature that required is higher than the ambient temperature, and in order to reduce condensing temperature at low ambient conditions during the night or during the winter season, and another opportunities by minimizing auxiliary loads such as circulating pumps or load requirement. Also, another issue by using algorithm controls economizers for heating, ventilating, and air conditioning system that allowing to maximize the time of the outside air that be used in order to maintain the temperature in each zone in order to save the energy for free cooling systems. As we see in this diagram, that's reference for cooling system, as we see that the outside air and with the outside temperature in this value entering the system through the economizer which opens at 60%, and there is another stage in this methodology, mixed air with this percent value and filter clean and fan through this duct, and also there is AC off, okay, and also there is another technique for supply temperature, and finally we have a circuit of supply air and return air, and the return air we have a damper about 40% open. This technique used whenever it is available condition that can help for the facility or the decision of top management to use. As I said, when there is a process temperature is higher than the ambient temperature, and this system is very interesting. Free cooling systems can achieve energy saving reach up to a value 20% as compared with traditional cooling system. Now, what are the typical opportunities for refrigeration and cooling system in buildings? Here, by optimizing time controls for plant operation and by using variable speed drives, and also by replacing current equipment if possible, of course, with more efficient equipment, and maybe by using heat pump that can provide cooling processes and heating processes of water at the same time, and also running more condenser fans in order to reduce condensing temperature under work condition at the situation of operation under lower load, and also by reducing air leakage such as using fast acting door or air curtains or strip curtains, or by using dedicated personal doors and so on. And also we check the industrial processes. What we must be check? Okay, by reducing energy service need such as lowering the process temperature or lowering the load, and checking the efficiency of energy generation, as example by using a gas burner instead of oil burner, and using heat pump in order to recover energy from cooling loads, and checking if there is a potential for alternative such as efficient technologies using, and if there is a potential of improving production planning such as run at full capacity and stop for a period instead of running at continuous for at partial load. And also there is important issue about the knowledge of the operators, which will be influence all his actions on energy use, and also review the maintenance and the quality challenges which may be caused for higher energy demand, and also the opportunity for improving insulation for heating and cooling industrial processes in the facility. Okay, now what must be checked for compressed air system in buildings? As we know that compressed air system represent the largest energy user, especially in the industry processing. So here must check the age of compressors and the number of stages for each compressor, and also checking if there is any leakage from piping system or valves, and also trying to minimizing the acceptable pressure, and also checking for a pressure drop across the air treatment plant, and if there is air inlet temperature, and checking the value of the air inlet temperature that entering the system, and also checking the temperature of installation space, and also checking the means of work, and if there is opportunity for installing another alternatives, and also checking the compressor sequence controls, and also checking the status of partial load operation for multiple compressor sites, and also checking if there is a proper air isolation on equipment lines when not in use state. Okay. And now for typical opportunities of compressed air system in buildings. The opportunities represent the isolating compressed air distribution system during out of production hours or period, such as zone control, solenoid valves, and also using isolating dead leaks, and also doing a pump up test when air using equipment are not in use, and also by installation of moisture sensing drain traps instead of manual air receiver blow down valves. And also we must know that by using heat recovery system in air compressed system, because the total efficiency of the compressed air system is very low, which in the rate of from 10% to 15%, and this gives us a big indicator of high level of heat loss, which equals about 85%. So the efficiency of compressing air system is very low, because we have a lot of sources of losses, and this heat can be used again by using heat recovery system. Okay. Now the last issue, technical assessment of renewable energy. As we know that renewable energy technologies can be or represent the central element in assessing the opportunities in a specified facility, because it can be used for energy reduction at low cost or no cost, and also this energy is friendly environmentally. I would like to focus on an important issue, that energy efficiency represents the first principle that should be always be applied to ensure that the energy requirement is minimized before any attempt to consider a new source of energy such as renewable energy. So we must check the energy efficiency at first and minimizing the energy requirement, and then we must think about renewable energy technologies as alternative for traditional energy sources. Okay. And also applying to reduce size of renewable energy systems that required in order to reduce the investment cost, and also by using renewable energy in building for heating purposes or for electricity supply. And also we can use this renewable energy to identify financial viability and maybe agree with implementation of renewable energy measures. Also, we must consider the measure that fits best with corporate of social responsibility objectives. At the end of this slide, I will finish my lecture. Thank you for all and goodbye.